welcome to our lesson on decimal word problems, gang. So here we go. Two things that we're really going to look at. Two things. One, let me let these folks in, but number one, why decimals don't necessarily make a problem harder. So I'm going to go ahead and talk to you guys about this for sure, because let me just ask an honest question. Have you ever done a word problem that you felt like you got stuck on specifically because of the numbers that you saw? Whether you saw a decimal or a big number or a fraction or a percent with a decimal in there. Has there ever been a time where you got spooked by a problem simply because of the numbers that you saw? See, it happens to all of us, right? It happens to all of us. It was an honest question. It happens to all of us. Now, here's the thing. What's the difference? Everybody, what's the difference between this? Find the sum of 1 plus 1, and then the same question asked, find the sum of 12.637 and 13/5. What's the difference between those two questions? What's the difference? Tell me, guys, what's the difference? Find the sum of 1 plus 1. Find the sum of 12.637 and 13/5. What's the difference? One's a fraction. One's a decimal. One's a fraction. One's a decimal, right? Okay, so you pointed out the what? The numbers. Now, let's point out the solution. Everybody, how are you going to solve this problem up top? Find the sum of 1 plus 1. What are you supposed to do? What are you supposed to do? Right? Add, right? If you didn't know, write this down. When we ask what's the sum, we're asking what's the total when added together. The sum means what's the total. So what's the sum of 1 plus 1? So what we would do is we would add 1 plus 1. Great. Okay. Everybody, how do you solve this problem? Find the sum of 12.637 and 13.5 or 13/5. Is there a difference here? Do we do the same thing? Do we do the same thing here? Do we just add here? The answer is yes. We're just going to add. That's all we're doing. Now, if you're looking at this and you're saying, but coach, we have a decimal, and coach, we have a fraction. That doesn't matter. They're just numbers. And so the first lesson of today, my math party people, is this. When you're doing word problems, remember that the numbers don't matter until you know what they mean. The numbers do not matter. They're just numbers. You're going to have whole numbers, negative numbers, fractions, decimals, percents. They're all numbers. If you don't know how to interpret them, you're going to get the problem wrong. I could give you 1 and 1. And if I said, hey, if I summed these two numbers, then doubled them, then cut them in half, what's the result? You could see 1 and 1, but if you don't understand what double, sum, divide, or quotient, if you don't know what those things mean, then you're going to have a bad time. So everybody, does it make sense to you, that the numbers don't matter until you know what they mean? And again, also, decimals, fractions, percents, negatives, they're just numbers. If you feel uncomfortable working with fractions, we can work on that. If you feel uncomfortable working with decimals, we can work on that. Again, they're just numbers. They're just numbers, and we can work on it. All right. Now, number two, it's a perfect segue, because if you're looking at me saying, hey, coach, yeah, decimals are difficult for me. What do I do? What can I do? Well, we're going to be talking about the rules for dealing with decimals. We're absolutely going to talk about that, so don't worry at all. We're going to cover them. But the two main things that we're going to be going over and learning today are, again, focusing on the story of the problem to make the solution, to figure out what to do, and then the how to do it. So the figuring out what to do, and then understanding perfectly how to do it. That's essentially what you're going to learn today, my math party people. So with that said, Catherine, no worries. We're going to have practice with decimals today, and fractions if you're in the program. Got plenty for you there. So here we go, my math party people. Let's go ahead and move forward here. These are your main notes. Has anybody ever seen this before? Yes or no? And if you have seen this before, is this ingrained in your memory by now? Yes, every week. And so if it's ingrained in your head, if you're doing a word problem and you hear my voice in the back of your head saying, what do you want? What do you have? What's the connection? One, I didn't mean it for it to be that creepy, but two, I hope it's helping you out. I really do hope that it's helping you keep calm when you start freaking out about a big word problem with multiple words or multiple sentences. So let's go through this, everybody. Let's go through it together. For those of us that haven't heard this before at all, to the person here who probably can recite this at 2 in the morning, waking up with a cup of water in their face, already dreaming about it. So with that said, here's the thing. Word problem is about storytelling. It's about understanding what the goal is and understanding how to sort through information and build connections. So the first thing you should always do in a word problem, number one, no matter what, is ask yourself, what do you want? Everybody, there's a 3-letter acronym that a lot of us like to write when we're doing word problem classes. And what is that going to be? Asvin, appreciate it. Elon, thank you as well. RTQ, which means read the question. Let's write that down. Let me go ahead and actually make this bigger here. Read the question, okay? Read the question. That's the first thing you should do. Think about it like this. Have you ever been convinced, whether by a friend or by a family member, your little cousin or little sister or brother or big brother, have you ever been convinced to play a game that you didn't know the rules for? They just said, try it, it'll be fun, try it. And then you play it. And then you figure out that in the first round, you hate the game because you don't know how to win. My whole life. But yeah, like that's the point I'm trying to make. Think about it like this. If you're playing a game and you don't know the rules of the game or how to win, pretty quickly you're gonna get frustrated. Or same thing is as starting a new job and they don't tell you what your function is. They don't tell you what you're supposed to be doing. They kind of just throw you everywhere and make you do a bunch of random things that you have no idea what the purpose of it is. That can get pretty frustrating pretty fast, right? And so think of it like this. If we go into the word problem, understanding exactly what we're supposed to be figuring out, even if we don't know how to do it yet, but if we know what we're supposed to be figuring out, you have already eliminated 50% of test anxiety. You've already eliminated it because a lot of the anxiety comes from not knowing. So boom, what do you want needs to come first. The next thing that needs to come is, well, now we're playing detective. I know what I want. What information do I have? What do I have to work with? What am I given here? And so when I ask you, what do you have? I'm asking you to basically take note of the information. This is your information here. So I'm going to go ahead and write this here. This is where you log your information, everybody. So with that said, my math party people, if someone could go ahead and type into the chat box for Maximo to go ahead and check his audio settings so you can hear me, please and thank you. But when you are taking down the information, everybody, you tell me, are you the kind of person when you write down information in a word problem, do you only write down the number or is there anything else that you write down with it or just the numbers? Like, what do you do? What do you do typically? Okay, so I see here that a lot of people here are saying, hey, the numbers, I write down the keywords as well. I like seeing that, love seeing that. Good, but the thing is, not enough people here are saying numbers and keywords. We want to make sure that we're not just writing the numbers, but what they mean. Again, like I said, the numbers don't matter until you know what you're supposed to do with them. In any word problem, I can change it from find the sum of 1 plus 1 to find the sum of 12.637 and 13/5. The process is the same. The numbers just changed. That's it. So you are not going to care about the numbers until you know what to do with them. So that's why you're going to write the information and so the information, which means the numbers and meaning. So numbers and the meaning or the keywords around them, like miles per hour or days or dollar amounts or ounces or weights, things like that. You want to attach the meaning with the number. And then lastly, build a connection. This is where you're playing detective. You know what you want to do. You have all of the information. Now build a bridge, figure out the process, figure out how to get the answer. Because I can guarantee you, if you can tell me how to solve problems, that is much, much better than someone who knows how to calculate quickly, but doesn't know how to organize word problems. Like if you were to give me two types of people, one person who's only good at building the connections, like the what do you want, what do you have, what's the connection, and the other person who only knows how to calculate quickly, I'd rather take the person who can tell me how to solve it over the person who only knows how to work with numbers. Obviously, the ideal situation is having both, which is what we're training for. But I'm telling you right now, it's more important for you to know how to do it than to know how to do it if you were served it on a silver platter. So with that said, let me go ahead and move this down. So take a screenshot if you need to. Actually take 10 seconds here to take a screenshot. And Joshua, no worries. I will, it's only on your end. Okay, I gotcha. I'm going to reset my internet tomorrow morning anyway. You're good. So go ahead and take a screenshot, guys. I'll give you a couple more moments because what we're going to do is we're going to go straight into some practice here. And I'm going to go ahead and just let you take this first problem and just try it out. I'm just going to let you try it out. Some of us might feel uncomfortable, and that's okay. I just want that shock value to really show you that, hey, look, this is what it's like when I do it on my own. And then eventually down the road in class, you'll see how it's done after some guidance and you'll see the difference. So let me go ahead and get my timer up. And let me just look at the problem real quick again to see how much time I should give you. Cool. I'm going to give you a minute, not to solve the whole problem, just to tell me what you're supposed to do and why. That's it. I don't want you to give me the answer. If you can find the answer, perfect, great, pat yourself on the back. But I only truly care about, do you know how to do this? So let me give you 1 minute right here. All right, there's your timer. And the timer has started. So let me go ahead and get that there. Perfect. And we are good. Go ahead. Take 1 minute here, guys. Just tell me again, when you're ready, just type ready. Don't reveal the answer, just type ready. But all I want you to do is when the time is up, can you give me a plan? Can you give me a plan? And to do that, you need to know what you're looking for. You need to know what the numbers mean. That way you can give me a plan. Because I can guarantee you, again, the decimals there, don't worry about it. You don't have to worry about it. All right, time is up. So go ahead and type out your answer if you have an answer. If you have a solid plan, type out what the plan was supposed to be. You know, in one sentence or less. Go ahead and give it a shot. Oh, and Justin, I saw that right there for the harder ones. I got you. With these ones, these warm-ups ones, I'm going to be guiding you guys through them. And I will, since you're part of my classes anyway, I'm going to go ahead and give you the opportunity for one of the ones down the road. So read the question first. You need to find out how much each marker costs, right? And boom. To find out how much each one costs, yeah, you got to divide. I love these replies here. I love these replies. Exactly. So let's go ahead and begin here, everybody. First things first, read the question. So with that, how much did each marker cost? Okay, sounds good. So everybody, there it is. We're looking for how much each marker costs, but what we're going to write down here, let me go ahead and change this up. We want, is it safe to say that we want the cost of one marker? And I know this problem might seem easy, but I'm just warming you up to the idea of how to process a word problem. because they're going to get more complicated as the class goes. I got you. So over here, it's safe to assume, right? We want the cost of one marker. And a key word here that we might want to really pay attention to is going to be each. Each is a definite key word that we always want to pay attention to, because half the time might mean multiplication, half the time might mean division. Typically, when you see the word each in the question statement, like when you're asking for each, typically you're dividing. And let me explain why. Because a lot of us, again, might have memorized that each means multiply or divide, but you might not know why. So here's the thing. Everybody, let's look at the information so I can really prove it to you. So when we look at what we have, just take a look real quick. If you need the proof, we have this much money spent, $19.24, and that was 4 colored markers. So what we see here is $19.24 for 4 markers. Now, here's my question, everybody. Here's my question. What math operations does it sound like we're doing if we're saying, hey, we have spent this much money on 4. We want to know how much money for 1. We spent this much on this many. We want to know how much for just one of them or each of them. What math operations does it sound like we're doing in that case? Right, it sounds like we're doing division here. And let me explain why. Let me just reiterate this and really reinforce this. If you're telling me that 4 markers together are $19.24, if we're trying to go backwards, instead of going with 1, 2, 3, 4 to get 19.24, well, think about it. What you would do is you would say, hey, if I know the cost of 1 marker, multiply it by 4 to get that $19.24. But it sounds like we need to work backwards. And what's the opposite of multiplication? Division. To find out how much each one costs, just divide. To go from 4 making this much down to 1, we would divide. Because when you divide by the total number, you get how much for 1. So there's our plan. Our plan is going to be divide $19.24 by 4. Now, is anybody here looking at this saying, hey, okay, coach, I get the connection, but I'm a little nervous about the decimals. Is anybody here nervous about the decimals? And no worries, David. Thanks for coming in, man. Is anybody here nervous about the decimals? Okay, and if it's just, even if it's a little bit, that's fine. That's fine.
And really quick, before we continue my math party, people, I know you're enjoying this, and you can have thousands of problems just like this in our program. In our program, you have 4 main things to help you succeed and more. But mainly, in our course, you're going to get access to recorded lessons, you're going to get access to guided practice just like this, worksheets that you can print out and try or keep them online, and lastly, speed drills to raise your confidence. That way, when you take the test, there's no test anxiety. There's no pressure because you've been timed before, you know what to do, and that's the feeling that we want. And all of that's included in our program and more. So take a brief moment, click the link here in this video or in the description to learn about the program, and then reach out to us if you have any questions. Sign up now, let's get going, and let's get back to the problem.
And so here, it says the connection here, divide to find each marker. Because you have the group of markers, and if you want to find each, you're dividing. So let's set that up for ourselves and let's get it done. So I'm going to zoom in just a little bit. Don't worry, I'm going to zoom out toward the end. I gotcha. But we're basically, again, dividing 4 into 19.24. So yes or no, everybody? Do you know how to do long division? Yes or no? If it was regular numbers, would you know how to do long division? Okay, the majority of us are saying yes. We do have some no's, and that's completely okay. I'm going to walk you through it anyway. Don't worry, I got you. I just really want to know, for me, who here understands long division without decimals. That way I can just show you what the similarities and differences are when there are decimals. So here, when you are dividing by a whole number, The process doesn't change, everybody. Again, when you're dividing by a whole number, nothing you got to worry about. Just divide it regularly. Wherever the decimal place is, you line it up with your answer, just like that. Just like with adding and subtracting decimals, you got to line up the decimals. When you're dividing, yep, you'll line up your dividend, whatever you're dividing, what you're dividing into, with the answer. Just line up those decimals, you're fine. Again, that's when you're dividing by a whole number. When you're dividing by a decimal, which we will be doing in a bit later on in class, I'll show you a neat little trick you can do to make sure that you make it look like this. Make it look just as easy. So here we go. When you're doing long division, just as a brief reminder, so 4 goes into 1, it doesn't. But next up, everybody, how many times does 4 go into 19? Right, 4 goes into 19 4 times. And the reason that's the case is because 4 times 4 is 16. So I'm going to write that down there, because again, 4 times 4 is 16, and I'm going to subtract that right here. So 19 minus 16 is going to give me 3. And what you're going to do is you're going to bring down that number, the next digit right there. So the next question, how many times does 4 go into 32? How many times does 4 go into 32? Right, that's going to be 8 times. And again, 4 times 8 is 32. So we'll just write that down right underneath, and we'll take it away. And we'll take it away. And so boom, that's going to be 0. Then we have 4 being dropped down. And so there, 4 goes into 4 how many times? Right, that's going to be 1 time, nice and easy. And we are good because that's a perfect fit. And so right there, there's your answer, $4.81 per marker, or for each marker. $4.81 for each marker. I'm going to go ahead and give you a little more space to take a screenshot if you'd like to, but there we have it. Right there. What we wanted was the cost of 1 marker, each marker. We had the total cost of 4 markers. And so we work backwards, divide to get the answer. And then you actually do it. Now, here's one thing I want to say before we move on to the next question here. My party people, and you answer, this is an honest question. Are you more confident when you know what you're supposed to be doing before you calculate, or are you the kind of person that doesn't stress when they do one step, look back to see what else is going on, then they figure out what the next step is and they do it, look back, next step? Are you the kind of person that is more confident when you're like, okay, I'm supposed to do this, then this, then this, and then you do it? Okay. And a way that I can relate this, and again, thanks for being honest, this is great. The way that I can really relate this is when you think about your GPS. When you think about, well, your GPS is doing everything for you. So if we were going back to the golden days, and you probably don't remember this, of MapQuest, when you had to print out your directions, the thing is, if you're the kind of person that does one step, then looks back, does the next step, looks back, you're going to be stopping a lot on the road. You're going to be stopping a lot. But before you leave, you know where your destination is, you know what your expected turns are, and then you go ahead and go through it. Yes, sometimes you need to refer to it, but not for every single little step, which can stop you a lot along the way. On the ASVAB, you only have so much time. So it's better to make the plan completely than execute the plan. And obviously, if you need to refer to a step real quick, if you forgot, sure, that's great because you already made the whole plan. But if you do one thing and check to see what the next step is, very, very, very high chance that you're risking starting off with the wrong step if you don't know how it's going to get you to the answer. So you want to make sure you know how it's going to get you to the answer. I am a little old, man. I'm a little old. Won't show it on my face though, but there it is. So with that said, yes or no, did that make any sort of sense before I move on? All right, great. So here we go. Coming up next, let's try this next one out, man. Let's try this next one out. So here's another one. So again, here's the thing. Start with the question, and I'm going to set you up with that. Then I'm going to give you a timer to actually solve the problem. So let's start here. Start with the question. How much money did she receive? Okay, everybody, yes or no? Is the question always going to tell you what math to do, or is it always going to tell you what you're looking for? Right, exactly. The question sometimes will tell you what math to do. Sometimes the question will say, what's the quotient of this, or what's the total, or what's the sum, or what's the product, or what's the converted temperature. Like sometimes it will tell you, but not always. What it's always guaranteed to tell you is what you are supposed to find every time. So don't look at the question expecting for literally, the sea to part ways for you to just cross over into the promised land. That's not going to happen all the time. Sometimes it will, but it will always give you what you're looking for. So this is why it's really important to understand the story of a problem, because the story comes first and then the numbers. So what we're looking for here is how much money did she receive? Everybody, can you imagine yourself receiving money? Just an honest question. Can you imagine yourself receiving money? Yeah, you can. I think we can all imagine ourselves receiving money. Great. Now, if you can understand a situation in your head, it makes it a lot easier to understand what math you're supposed to do. Watch this. So here, last Friday, Zuleika had $28.57. Over the weekend, she received some money for cleaning the attic. She now has $44.20. How much money did she receive? So if we're looking at this, again, what we want, the amount of money received. So bam, blank dollars received. Okay. Now, the information that we have is that she started with $28.57, ends with $44.20. So everybody, if you're asking me how much money did she receive, think about the order of the events in your head first. Like, walk yourself through it. And again, I know that this is a simpler problem, but we will move into more complicated ones as class goes on. But as we look at this, it sounds like start with this money, you added some money to that, and then you end up with this much money, with the $44.20. Does that seem like a pretty fair assessment, everybody? You start with this much money, you earn some money, now you have this much. You're looking for the gap. What happened, right? So everybody, what operation is that? To figure out how much is between start and finish, what operation is that? To figure out what is between the start and the finish. Subtraction, exactly. It is subtraction. Booyah. That's the plan. That's what we'll do, and we'll execute it. And so what I'm going to do is I'm going to walk you through addition and subtraction with decimals. I'm going to walk you through that right now. So step 3 here, subtract to find the difference. To find the difference. Okay, sorry for the chicken scratch there. I will go ahead and make sure to write better going through it. And so here, sweet, we'll do 44.20. We'll subtract the 28.57. And let's go ahead and get to it. So remember this, everybody. Look at what I just did with the decimals here. I lined them up. And I want you to go ahead and make sure you write that down if you are struggling with adding and subtracting with decimals. Make sure to line up your decimals. So adding, subtracting fractions, or decimals, excuse me. Line up the decimals. All right, line up the decimals. And then what you'll do after that, everybody, simply subtract as normal. Do the whole borrowing thing if you have to. As long as you're good, you're good. If you know your mental math with decimals, obviously you're probably looking at this like, oh yeah, I know this. And cool, happy for you all day. Now, if you don't know how to do that, don't worry. Got plenty of videos on that in the math bootcamp. But for here, we're going to go ahead and do it the normal way, the traditional way. And we'll go ahead and borrow where we need to. So we'll go ahead and get this done. Borrow from there. 10 minus 7 is going to be 3. Now I'm doing 1 minus 5. Can't quite do that. I'm going to borrow from that 4 next door. So now we have 11. Everybody, what's 11 minus 5? Right, that's going to be 6. Line up the decimal. Again, keep it exactly where it was. And now we have 3 minus 8. Can't quite do that. And so from here, we'll make that a 3 to make this a 13. 13 minus 8, what's that going to be? That's going to be 5 right there. And now we have 3 minus 2, which is what? And that's going to be 1. So again, look at what I just showed you. Subtracting with decimals is literally the same as subtracting with regular numbers. All you got to make sure you do is line up the decimal places, and you're good. Make sure the place values line up. Your hundredths place, your hundredths place, your tenths place, ones and tens. Just make sure it lines up, and you're good. Make sure you line it up, and you're good. And boom, yeah. And to check your work, you can add it back in. Exactly. To check your work, you can tell the story. So there's your answer. Let me go ahead and make it so that you can take a screenshot if you'd like to. Right there. And let me actually make this a little bigger for you. That way, if you are taking a screenshot, you can make that a little bigger for yourself. Right there. So boom. So there we go. Feel free to take a screenshot if you'd like to. There is that. But again, if you want to go ahead and check your work, tell the story. You started with this much. Add the 1563 to see if you end up with 4420. Tell the story, check your work. You can give yourself so much more confidence when you know that it works instead of having to ask if it works. So, yes or no, has anybody here felt more confident or felt that they didn't even need to have to ask for someone to check their work because they knew exactly how the number and the answer fit in the story? Cool. That's the goal. That is the goal. All right, so moving up next, this next example, everybody pay attention. Right now, up next, we're going to go into a different, I wouldn't say this is it could be harder, could be easier depending on how you look at it. But what we're going to look at next is a problem that takes more than one step. Very often on the ASVAB, you're looking at problems that not just, that don't take one step, but 2 steps or 3 steps. Sometimes 4 steps if the numbers are easy enough to deal with. But here we go. You're going to have here a 2-step problem now. And again, I'm going to throw it at you and I'm going to give some hints, but I'm going to time you for 2 minutes. I don't expect an answer. I only expect, hey, can you identify what we want? Can you identify what we have? Can you make a plan? Can you make a plan? Can you tell a story? So here we go. Here we go. Can you identify what you want? Can you identify what you have? And the connection. Here's the timer. 2 minutes. And here we go. So here we go, everybody. What does the question read? Again, don't worry about any of the information. Don't worry that these are decimals. Don't worry about that. Worry about what we're supposed to figure out. What are we trying to do here? You know, instead of opening the door and then seeing a tornado with a lion and a bear and a tiger, instead of that, read the directions on the door. The directions on the door say, when you open the door, quickly pick up the pen and close the door. You'll win $1 million. If you read that before going into that room with the lion and everything else and a tornado in there, I feel pretty happy. I'd be like, okay, just open the door, grab the pen, I get $1 million. As opposed to grabbing the note, not looking at it, opening the door, closing it behind you, seeing everything that's going on. Do you think you're going to be focused on the directions? No. Get the directions before you start. The directions here are this. How much did each pen cost? Right there. So number one, what do we want? We want the cost of each pen. for each pen. Everybody, here's the thing. Before we look at the information, the math is hidden here. The math is given to us here. Everybody, when we see each in the question, it is very likely that we are going to what? What operation at some point? When we see the word each in the question, we are likely going to do what? Divide. And why do we know this? Here's why, everybody. If we're looking for the cost of each pen, think of it like this. If I had how much money I spent on the pens, and if I had the number of pens, isn't it true that if you divide the amount that you spent by the number of pens, you will get the cost of one pen, of each and every single pen. Like let me keep it simple for you. Forget the decimals. Let me keep it simple for you. If I told you I spent $10, if I told you I spent $10 on 5 ice cream cones at Twisty Treat down the road, if I spent $10 on 5 ice cream cones, everybody, how much did each ice cream cone cost? Go ahead.
And before we continue, my math party people, really quick before we continue, I know that you're enjoying this video and I want to make sure that more people can enjoy these videos just like you. So if you wouldn't mind, just take a quick second, like this video, comment on it, just showing some appreciation, showing what you learned, and then make sure you're subscribed to the channel so that way when we come out with new videos, typically every day, you can be right there on the spot to catch on to them. So help us help others ace the ASVAB. I'm Anderson. Let's keep going here.
If I spent $10 on 5 ice cream cones, how much did I spend per cone, for each cone? $2, right? Justin, when we go to the time practice, I got you. That's where I'm going to open up the conversation to everybody. I got you. But yeah, $2, right? $2, everybody. Because you know that if you have the total amount that you spent, the $10, divided by the number that you got, 5, you get the cost for each one, $2 per cone. So let's apply the same logic here, even though we're dealing with decimals. That's okay. That's fine. That's fine. If we want the amount for each pen, the way that we're going to do that is like this. The cost for each pen means the total money divided by the total pens. So the total money spent on pens divided by the number of pens. Excuse me. Let me make that a little easier to comprehend. So the total money spent on the pens and the number of pens. That's going to equal the cost of each pen. That's going to give it to you. But let me go ahead and write the information down and show you exactly why, even if some people know that, we'll still get the answer wrong. And it's because, again, you're looking at the numbers, not the information. So here's the information we have. We have the $24.31, right? You had, that's how much you had. Then you have the 6 pens that you bought. 6 pens purchased. And then you had $3.49 left after the purchase. Everybody, are we going to deny it? Is this information true or accurate? $24.31 is how much we had. We bought 6 pens, and $3.49 is what we are left over with. That's the leftover. Okay. So let me show you why this is a 2-step problem right after I get rid of the timer so I can get more space here. 2 seconds. All right, cool. So here's the thing, everybody. Are we supposed to divide the $24.31 by 6? Are we supposed to divide the $3.49 by 6? Which one of those are we supposed to divide by 6? Hey, no worries, Josh. Which one are we supposed to divide by the 6? The $24.31 or the $3.49? All right, so would you be surprised if I said neither? You're not supposed to divide either of those numbers by 6. Because let me explain to you, everybody. You need to understand that it's not about the numbers, it's about what they mean. Over here, just take a look with me. Take a look with me. Zoom in over here with me. Oh man, that's nice and close. Look at the red right over there. Everybody, right? Look, the way that we're going to get the cost of each pen is by dividing the amount you spent on all the pens by the number of pens. Did the problem tell you that you spent $24.31 on the pens? Did it say that you spent $3.49 on the pens? No. The $24.31 is how much you had in the beginning. The $3.49 is what you had after you bought the pens. So the amount that you spent on the pens is not yet here, but we can figure out what that is. Everybody, does that make sense? Neither of those numbers represent the amount of money you spent on the pens. This just tells you how much you had when you started. This just tells you how much you have when you finished the purchase. Neither of them are the actual total amount that you spent only on the pens. So how can we figure out how much we spent on the pens? Right, we need to subtract. So I see a lot of people here having light bulb moments. I love it. Please use emojis, use whatever you got to do, like make me laugh. But yeah, so I really want to make sure you understand that it's not about the numbers, it's about what they mean. I could switch up the numbers right now. I could tell you that it's 5 pens. I could tell you that you had $27 when you started, $2 when you finished. The process is the same, even if the numbers change, even if they change. So we're going to subtract. So to get the total spent, right over here, to get the total spent, you're going to subtract. To get the total spent, you'll take the $24.31 and you'll subtract the $3.49. That's exactly what you'll do. That is exactly what you'll do. And then from there, everybody, this is how making a plan looks like. After we subtract those two numbers, first of all, let me do a quick check with you. Once I subtract the $24.31 and the $3.49, whatever number it is, what is that number going to represent? What is that number going to mean? Quick, in the chat box, what is that number going to mean? Kevin, that's right. AJ, yep. Exactly, how much you spent on the pens. Okay, so notice how we don't even know what the number is, but we know what it means. And now think about it like this. Once I have the amount that I spent on the pens, what am I supposed to do with that number? What am I supposed to do with that number? Once you have the amount that you spent on the pens, what are you supposed to do? Divide it by the number of pens, which is 6, right? You got to figure out what the total amount you spent on the pens was. You got to divide it by the number of pens. What that means is, after you're done subtracting down there, take that number, divide it by 6, and you have your answer. Done. So that's what I meant earlier when I said, if you can make a plan, even if you didn't execute it yet, if you can tell me what the plan is, you can look at a very similar problem and be super confident that you know what to do. That's what this is about, everybody. It could be fractions, decimals, negatives, percents. I do not care. If you can tell the story, you can build your confidence. So here we go. 24.31 minus 3.49. Let's go ahead and get into it. What if you divided first and then subtracted? It'd be wrong. It'd be wrong. Simply put. Simply put. So with that, here we go. 24.31 minus 3.49. Let's go. 1 minus 9, you can't do that. So here's a 2 and 11. 11 minus 9, everybody hit me. Dominic, don't we all, right? We all wish we had that question. So that's going to be 2 right there. Great. Now we have 2 minus 4. Can't do that. Let me go ahead and borrow right here. So now we have 12 minus 4. Everybody, what's 12 minus 4? It's going to be 8. Sounds good. All right, great. Make sure, again, always line up the decimal places when you're adding and subtracting with decimals, just like you line up the place value. Same stuff. Now we have 3 minus 3. What's that going to be, everybody? That's going to be 0. Sounds good. And now lastly, we have 2 minus nothing, when that's going to be 2. Cool. Everybody said the answer is $20.82, the answer. No, I'm glad that you understand that you're not done. Exactly. Now we need to, just like Kevin said, divide that number that we found by 6, and then we're done. Dominic's question was, when you subtract, you put the number on the, I put on the bottom. I'm not sure what you mean by that question. There might be something I'm missing there. but you want to line up the place value, line up the decimals. So these decimals, line them up. Line it up. Line it up. Yeah, make sure to line it up. So now that we have that, the $20.82, what did we say? Now we have the total amount spent. Great. And so we're going to take that $20.82 and divide it by 6. That's going to give you the cost of just 1 pen. That's the total for 6 pens. Divide by 6 to get 1 pen. So here we go. Let's get it. So we'll do 6 divided into 2082. And let's put in that work. So everybody, 6 goes into 20. How many times? Boom, that's going to be 3. Great. And I'll go ahead and tell you exactly how to check your work once you're done. Don't worry, I got you. So we see here that it goes 3 times. We'll subtract the 18. That's going to be 2. Bring down the 8 for 28. Okay. 6 goes into 28. How many times? Right, it's going to be 4. So we have 3.4. So 6 times 4 is what? We should know this. 24. Sounds good. There we go. Bring that 4 down. And then we're going to bring this 2 right over here. We got 42. Everybody, 6 goes into 42. How many times? Booyah, yeah. That's going to be 347. And that's going to be 347. And there you go. And there you go. Now, there is another way that you could do this that you think wouldn't make sense, but it does work. You could divide both of those numbers from the beginning. You could divide both of these by 6 and then subtract them. And that would work. That would work. Funny enough, it would. But you have to understand that, yeah, what you're basically doing is splitting glue at that point. And you're not going to get pretty numbers here. You're going to get some repeating decimals. And that might be really frustrating to a lot of people, not being able to see how that actually works. But long story short, 347. Are we done? Is it 3.47? Yeah, exactly. We don't have the time either. But yeah, that would be the answer. Yeah, David, go ahead and type out your question for this one because we do have our time practice right after this. Yeah. So go ahead and type that out. Dominic, yeah, go ahead for sure. Go ahead. So yeah, 347 per pen. Per pen. I'm going to go ahead and make my face disappear for a quick moment so you can take a picture of the problem. So let me go ahead and zoom in on this real quick. Actually, no, I don't need to. No, cool. Enough space. Go ahead. Go ahead. Go ahead. Okay. So let's talk about checking our work here. So a lot of people are asking, hey, okay, if we get a number, how can we know that that's the answer? How can we check our work? You know, the answer is going to be C, $3.47. And the answer is the same. Can you tell the story? The story being, hey, look, you started off with $24.31 for those pens. You spent that money on 6 of them. You got $3.49 left. Now, if you have your answer, $3.47, here's the story. The story should be, hey, if you go with the 349, how much money you end up with, if you add back the money you spent on the pens, you should get back to the $24.31, correct? If I start off with what I ended with, I add the money that I spent back, I should get $24.31, correct? And Dave, I'm going to hold that question for you right there. I see you guys are saying yes to the previous question. Sounds good. So with that said, think of it like this. If I take $3.47, the cost of each pen, multiplied by 6, that would be the cost of 6 pens. If I take the cost of 6 pens, add it to that money I had left over, I should get to the $24.31. If I do that and check my work, I will get back to $24.31, and I can verify that I'm right. And you can verify that you're right as well. You can absolutely verify it. By putting the number back into the story, you'll see that it works. David's question here, would the placement value be different if the 6 was a decimal like 0.06? Yeah, for sure. When we run into a problem like that, again, I will explain it. I will take plenty of time to explain it. But if you remember my class on decimals, I believe it was 3 weeks ago or 2 weeks ago, my class on decimals where I went over how to divide by decimals, make sure to look at that. Make sure to look at that for sure. I also have an entire little series on that in the Math Bootcamp for guided practice videos on decimals. So make sure to go there. Right, he could have bought 7 pens for sure. Could have bought 7 pens. But there it is, my math party people. Who here is ready to try out problems where we are going to be timed? Give it a little more than 2 minutes, but who's ready to be timed and try some more problems out? All right, cool. And so for these problems, I will allow some of us to raise our hands and explain their thought process on the problem. Definitely going to allow it this time. But the catch is I'm only going to allow people in the program to do it. Okay. Only going to allow people in the program just because for some reason, when I'm allowing people that have not been in my program and just coming in for the first time or second time, some of y'all, I'm saying all y'all, some of y'all are not here to say nice things. I don't know why. But with that said, I'm going to go ahead and keep it to those in the program. All right. So with that, here we go. As a reminder, my party people, remember, storytelling is everything. Start with what you want, proceed with what you have, and then make the connection. So start with the question, then the information, making sure you know what the information means so you can build a connection to the answer. 1, 2, 3. All right. Now this says 2 minutes per question, but I'm going to actually up it. I'm going to give you 2 minutes and 30 seconds. Now, here's the thing, everybody. Here's the thing. You must, and I mean you must, at least try to come up with a plan before you do any sort of adding, subtracting, multiplying, dividing. I don't care. Make sure you have a plan before you do any of that. That way you can feel confident that you know you would have solved it even if you ran out of time. Deal? Also, did you see that Eric passed? Eric, where you at? Hey, you got a 60. Let's go. Let's go. You know, this deserves a yurt. Everybody go ahead and give me the first yurt I've heard in 2 weeks, please.
Y'all my boy. 8.6 in the building. What are you talking about?
And boom. All right. So with that, Eric, my man, let's go. Did you qualify for the job that you wanted? Did you qualify for the job that you wanted? That's really the most important thing. My man, let's go. Let's go. Eric, hit me up, please. You got my number, right? Hit me up, man. I got to make sure that I get you on the Hall of Fame. For sure, man. I got to get you on there. And also, David, I almost forgot to tell you because I meant to text you about this. David hit me up. Do you already have an ASVAB shirt, David? Yeah, Eric, please hit me up. Thank you. I'm glad it does, Jalissa. But David, let me know if I already sent you an Ace the ASVAB shirt, because if I didn't, David, I want to send you one for free. Just because like I've been looking at some of the tape and you've been participating very, very well. Even after you passed the ASVAB already, you've been coming back and doing your thing. I want to send you a free shirt. Okay. So let me know, David. But with that, everybody, let's go ahead and get started here. Again, what do you want? What do you have? What's the connection? So let me go ahead and get this timer up right now. And let me go ahead and put the extra 30 seconds on there. 2 seconds, everybody. All right, 5, upping it up to 35 here. All right, perfect. All right, time starting right now. Here we go. First question starting now. Again, sometimes it's about the numbers, like how difficult the numbers are. Sometimes it's about making a solid plan. Make that solid plan. Let's go. Eric, I just saw it right there. Let me go ahead and actually reply to that right now. Boom. Eric, I just sent it to you. Feel free to be as detailed as you want to be, please. Feel free. Yeah, remember to type ready when you're ready, everybody. Don't reveal the answer. But again, plan first. Plan first. Question, info, then plan. Oh yeah, by the way, Eric, I know I sent you a Google review because what we do is we pretty much copy the text that you sent. If you want to send me a picture as well, whether it's you at Maps or any picture that you want, really, but we will go ahead and put it up on the website. If you haven't seen the ASVAB Hall of Fame, I'm going to go ahead and let me just grab it real quick. And so here it is. Everybody can see it right here. Here's where I put everybody who's passed with us. We have another round to do at the end of the month from everybody who's passed in July and June. So we're gonna go ahead and take all those folks and put them up there. So I put the link there for anybody who wants to see the reviews, because I know that looking at reviews and how other people have done, it really affects, you know, whether you want to be part of this program or not. So if you look at the text right there, I know I shut down the mic, or I shut down the chat box. If you would like to go ahead and take a second look at the reviews, there they are. That is our Hall of Fame. All right, I'm gonna give you guys the chat box again. There it is. Greg, what? All right, that is time. So remember, everybody, you can give your answer, but if you don't have an answer quite yet, but you do have a plan, type out, I have a plan, or you can give the plan. If you were stuck or confused, hey, say it. Say I was stuck or confused, but I want you to tell me what you were confused about. Were you confused about the question? Were you confused about the information? Were you confused about making a connection? Let me know. Like, I want you to really practice this, because this is how you're going to practice on your own. I can't always be there, right? I'm here Mondays, Tuesdays, and then Coach Sheen is here on Wednesdays, but there's so much more studying to do. I'm teaching you how to empower yourself to go from where you are to where you want to be. So tell me, if you were stuck, tell me where you stuck on identifying the question, identifying the information, making a plan. Which one of them were you on it? So you were stuck on making the plan, the connection? It's B. I don't know how I got the answer though. Okay. Okay. There we go. I'm looking at some of y'all right now. Okay. Okay. So here we go, guys. Starting with the question. What was the total bill? Okay. Everybody, first and foremost, who here, yes or no, who here thinks that when we say total, we mean always add it all up? Total means add. Okay, cool. So I see some of us saying yes, some of us saying no, and I want to remind you that finding a total just means finding the entirety. You can find a total by counting. You can also find a total by multiplying. You can find a total by adding. Yeah, there's plenty of different ways to find a total, but it doesn't only mean adding. It doesn't always mean adding. So here's an example, everybody. If I say I have $2, $2, $2, and $2, if I say what's the total, you might be able to discern or infer that if I have 2, 2, 2, and 2, I add them all up and I get 8. Woo, yeah, awesome, right? Cool. But if I said, hey, I bought 4 ice cream cones and each of them was $2, what was my total bill? That's not adding, that's multiplying. $2 a piece. We had 4 of them. 2 times 4, that's 8. Notice multiplication was done to get a total. That's fine. I need you guys to get that out of your head that if you see total, you're automatically adding. Not the case. Not the case. Total just means find the entirety. And that can mean adding a bunch of parts together. That could mean doing multiplication here and there. But ultimately, the goal, what total means, is find the entirety. Got to make sure I say that, okay? It really depends on the question, yeah. But it always means find the entirety. How you get there might be a little different from question to question. So with that said, here we go. The total bill basically means find the total payment, right? So what we want is the total payment slash bill. If you want to just keep it to the word bill, that's fine. That's all good. So here we go. Let's look at the information here. And actually, Justin, I'm going to call on you because you've been patient, man. Appreciate you. Justin, what did you notice about the information that may have tricked some people? Go ahead, Justin.
So what I noticed, it said, well, probably like to split the bill, because in order to split, that means divide. Like in my eyes, that means divide. But I didn't fall for that. So when they said each person paid $15.94, and I seen there were 7 people paying, what I did was I multiplied the $15.94 times the 7 instead of dividing 7 into either A, B, C, or D, because that would take longer on the test. And then that's how I got my answer.
Okay. So, Justin, thanks for explaining the process. But I'm going to go ahead and say that you may have mixed up one of the numbers. And so let me go ahead and explain why, Justin. I got you. Because first of all, I'm going to go ahead and praise you for what you did right. And what you did very, very correctly was, again, not getting tricked into the split the bill evenly. Okay. Think of it like this, everybody. When you split the bill evenly, what are you talking about? Are you talking about splitting the total bill amongst all the friends? Divide the total bill by the number of friends? Is that what you're saying? Yeah, no, it is already in the group. But let's answer the question that I just asked it. Right, for the total bill, yeah. Right? If we're splitting the bill evenly, we would take the total bill and divide it amongst the number of people, and you would have how much each person paid. But we're not looking for how much each person paid. We're trying to find the total bill. So we know that each person paid $15.94. We need to multiply that by the number of friends to get the total bill. Because think about it. If you're at a restaurant, each friend pays just $15. Forget the decimal, $15. Each person pays 15 times the number of friends. That's your total bill. Now, here's where a lot of people messed up. A lot of people messed up by multiplying by 7. Let's go ahead and do this here. What we have is $15.94 per person. And I'm going to ask this question one time right now. Everybody, how many people were eating dinner? Because it's $15.94 per person. Multiply by the number of people eating dinner, get your answer. Notice how we have some people saying 8, some people saying 7. This is the point of class where I would typically say, grab some drywall, get your knuckles ready, punch through it a couple times, make yourself feel better, and then get back in your seat and keep learning. Because this is one of those moments where you can very easily miss information. It says Jack and 7 of his friends. Everybody, how many total people is that? If I said, hey, me and 7 of my friends are having dinner, how many of us are there? That's 8, right? That's 8. And I think a lot of us got that. Some of us might be sitting at your desk or your bed or your couch, ready to flip your laptop or your phone across the room. But this is just one of those very teachable moments of just saying, hey, I just read too quickly. That's okay. That's completely okay. That's completely okay. Make fun of yourself, have fun with it. It was literally like a wow moment. And the reason I'm telling you it's okay is this. For those of y'all that wrote 7, for those of y'all that mistook it and thought 7, did you still do it the right way? Did you still know that you were supposed to multiply the number of friends by that $15.94? Did you still know that? And that's the point I'm trying to make, everybody. Like, that's a win. You knew what to do. You just mixed up a number. That's it. But you knew what you were supposed to do, and that's a beautiful thing. That's progress. But you just missed a small detail. And so cool.
Hey, really quick before we continue, if you're watching this, you've likely have already been to one of my classes. And if you haven't been to one of my classes, remember to check that schedule. The link is right up there and in the description of this video. That way you can understand when my free classes are and my Access Program classes are. That way you can keep raising your score, knowing what topics we're doing, and get the job you want. So again, click there or in the description to see when the classes are and join one for free. I'll see you there, my party people. Let's get back to the action.
So with that said, yep, if you didn't get got, that's fine. So you had $15.94 per person, and you got 8 people, or 8 persons. I'm just gonna say per person, you have 8 persons. And so what you're gonna do is $15.94 times 8, and there's your answer. If you would have done it times 7, you would have had yourself at this here, at B. But B is not the answer, it is gonna be D. So right there, 4 times 8 is gonna be 32. Boom. Then 9 times 8, that's going to be 72. 72 plus 3 is 75. And let me actually get rid of that decimal and bring it back at the end here. Then 5 times 8, that's going to be 40. Bring that 7 in, that's 47. Then 1 times 8 is 8. Add the 4 is 12. And here's the quick tip, everybody. When you're multiplying with decimals, remember this. When you multiply, notice how I kind of ignored the decimal. Just ignored it, I didn't care. And that's what you should do when multiplying decimals. When multiplying decimals, ignore the decimals, bring them back at the end. We have 1, 2 decimal places. So we'll go 1, 2 decimal places. $127.52 is your total. Total bill right there. And boom. So again, if you got B, that shows that you knew the right procedure, you just missed a detail. If you got D, it means that you knew what to do, you picked up on the little detail, and you're feeling pretty good right now. So how are we feeling about this one, everybody? How are we feeling about this one? Yeah, I just let you in. I got you. That was you, Shanique, right? Yeah, I got you, Shanique. I just let you in. Perfect. Perfect. Right, you just got to pay attention to that small little detail. Yeah, just got to make sure you read it. Because again, it's not about what the numbers are, because notice how a lot of us fixated on the number. Oh, 7, write down 7, write down 7, write down 7. What does that 7 mean? Because you know that what you should be doing to get the total bill, multiplying the amount per person times the number of people. Is 7 the number of people? It says Jack and 7 friends. That's 8 people. Boom. Unless one of them has multiple personalities, maybe 12. I don't know. But the problem says 8. So we got to go with it. So next up, we got a 2-stepper coming in, everybody. We got a 2-stepper. Who here thinks that they can handle this 2-step problem? Who here thinks they can handle that 2-step problem? And we'll see. I like the stoic attitude. We'll see. Not too high, not too low. And remember, everybody, don't get too high, don't get too low. Just take every new problem as a new problem. What's the question? What information do we have? What's the connection? Here we go. So here we go. Question. First things first. Question. Remember that the question always starts with the who, what, when, where, why, how many, which is the following, all that good stuff. So right here, how many candy bars did you buy? Okay, sounds good. So what we want is how many candy bars we purchased. So want is blank candy bars bought. Right there. Sweet. So remember, everybody, When it comes to step 3, what's the connection? It's always about how does what we want fit into the situation? How does it fit into the information we have? What is the story every single time? So watch how we do this here. And I know some of us might be thinking, oh, coach, you know how to do it and you make it look easy. That's not the point. I want you to pay attention to how I arrive at these conclusions. So first things first, how many candy bars we bought. My goal is going to be to figure out how do we fit the number of candy bars that we bought into the story? Where does it fit in? Mathematically, where does it fit in? So here we go. Step 2. What do we have? Here's what we have right over here. We have Ming, who spent $19.40 on a magazine and a certain number of candy bars. So let me go ahead and just outline that for us right here, my math party people. We have $19.40 spent. Okay. And what was it spent on? It was spent on right over here. It was spent on a magazine. One magazine, which is again $2.60. That's what the problem says right here. Magazine is $2.60. And over here it says every candy bar. And I'm actually going to use blue for that. Each candy bar, $4.20. Okay, great. So blank candy bars, and it was $4.20 each. Question, my party people. If I wanted to know how much I spent on just the candy bars, what can I do with the information? Like if I knew how many candy bars I bought, and I know that they're $4.20 each, what could I do with that information to figure out how much we spent total on just candy bars? If we know that they're $4.20 each, and if we knew how many we actually bought, what would we do? We would multiply going forward. If we knew the number of candy bars, we would just multiply to get forward to the total cost, to the total amount. But we don't have that, right? So something should tell you that we need to work backwards. All right. So here's how that's going to work, everybody. Here's how that's going to work. Here's where the connection comes in. Here's where the story comes into play. Think of it like this. If you want to know the number of candy bars bought, and you know how much each of them costs, and potentially you can figure out how much you spent on just the candy bars, what you need to realize is this. If you knew the total amount for candy bars, and you divide that by the cost of each candy bar, that's going to give you the number of candy bars. And if you're asking me, Coach, how do you know? How do you know? Well, here's how I know. Let's look at a very, very, very simplified example. If I said, everybody, hey, and again, let's go back to the ice cream cone example. If I said, hey, I spent $15 on ice cream cones, and each cone was $3. Well, think about it. If I spent $15 total and I told you that each cone was $3, everybody, what do you do to figure out how many cones you bought? Right, we would divide in that instance, right? We would absolutely divide in that instance because you're saying, hey, if I spend $3, then $3, then $3, how many $3 can fit into the 15 total dollars? That's exactly what we're doing here. But some of us might be stuck right now because we're looking at a decimal, $4.20. So here's what I'm going to suggest. Get over it. Work on your decimal game. Work on it, work on it, work on it, because that should not hold you back from having a great idea. Remember, there's the idea and there's execution. I don't want your ability to be nervous about the execution to get in the way of the idea. I don't want it to get in the way. So here's what you're going to do, everybody. First of all, we know how much each candy bar costs, right? $4.20. We know that. We know that. But everybody, do we know how much we spent on the candy? Is it going to be the 1940? Is it going to be the 1940? Is it going to be the 1940? Let me get that timer out of the way. Let me get that timer out of the way. Is the 1940 how much we spent? No, right? Let me go ahead and lay it out for you plainly. I want to make sure I lay it up for you nice and easy here. So think of it like this, everybody. If I take the 1940, which is again the magazine plus the candy, and I subtract the $2.60, which is again the magazine, is it true that if I take away the cost of the magazine from the 1940, is it true that if I do that, even though I don't know what the number is it true that we're going to be left with just the candy? Just how, like the amount that you spent on the candy. Is that true? If this represents the magazine and the candy, you take away the magazine, you're left with the candy. Is that rational? Is that reasonable? And you have to ask yourself that. Is that reasonable? Boom, and get it done. And get it done. So with that, booyah, there you go. And so we'll go ahead and do the math right over here. And let's get it done. So boom, 0 minus 0 is 0. 4 minus 6, can't quite do that. So we'll go ahead and borrow. Everybody, 14 minus 6 is going to be what? Yep, that's going to be 8. Perfect. Put the decimal again, line it up, line it up. Line up those decimals. And then 8 minus 2 is 6, and then 1680. Sweet. Well, and by the way, if you like the way that this class is going and it's your first class, I am going to be talking about the program very briefly after the next problem, and then we're going to end class, okay? I'm going to give you the link for it, discount code. If you like it, boom. I'm happy that you can raise your score with me. But we have 1680, and that's how much money you spent on just the candy. That's how much money you spent on just the candy. So what did we say we would do? Just look at your plan. We said the cost of the candy divided by the cost for each candy, like the total cost of the candy divided by the cost for each candy. That's going to give us the number of candy bars we bought. Sweet. So let's go ahead and do it. But here's the only problem. The only problem is when you do 1680 by 4.2 or 4.20, because again, 4.2 and 4.20, same thing. Here's a quick little shortcut when it comes to decimals. Dividing by a decimal. Remember that you always want to divide by a whole number. So what you can do, my math party people, is this. Everybody, true or false? Whatever you do to the top, you do to the bottom when it comes to fractions. Right? Whatever you do to the top, you do to the bottom. You will not have a good time if you try to do 4.2 or 4.20 divided into 16.80. It's not going to be as easy as you might think because you don't know what to do with those decimal places. So instead, just go ahead and move the decimal places in the same direction, in the same way, to make it so that you're dividing by a whole number. Think of it like this, everybody. If I had, let's go ahead and say 10 divided by 2. Everybody, quickly, what's 10 divided by 2? Quickly. 5. Okay, great. What if I went ahead and said, okay, let me go and take those decimals, because again, 10 is the same thing as 10.0. So if I went ahead and just moved it over to make it 100 over 20, everybody, is 100 over 20 still 5? Yeah, same thing. Same thing. So all I'm saying is move those decimals over just like we did here to make it 168.0, but just 168 divided by 42. That's how you do it. Gives you a much better number relationship to deal with, and you don't have to worry about the decimals all the time. Boom. So there you go. We're going to do 42. So this right here turns into 42 divided into 168. That's a much better problem to look at, much easier on the eyes. Let's get it done. So in this case, booyah, we're going to ask ourselves, how many times does 42 go into 1? It doesn't. 42 into 16? It doesn't. 42 into 168? Now we're doing the guess and check game. Oh, man. If you know your mental math, you know what I'm going to say. If you know your mental math, I'm going to tell you to divide by 2, then by 3, and then by 7. or divide by 2, then divide by 21. If you know your mental math, I'm not going to explain all that. I'm going to do it the regular way here by guessing and checking. And if you guess and check, you'll realize that 42 times 4 gives you 168. And again, you do a little bit of guesswork there, a little trial and error, boom, but you'll get it. And you'll get 4, and that'll be 4 candy bars. That'll be 4 candy bars right there. So yes or no, everybody, did that make sense? Not just the calculations again, but the procedure. That's really what I care about the most. And I'm going to go and get myself out of the way here. Or actually, I can do this. No, I cannot do that. I was horribly wrong. So let me go ahead and try to get my head out of the way. Take a quick screenshot if you'd like to. So again, the connection is, hey, if you have the total amount that you spent and you know how much each one costs, divide to get the number. Divide to get the amount. And it takes a little bit of time here for sure to understand how the divisions and multiplications, like to go from totals to parts to totals. I definitely get it, for sure. Definitely get it. But we need to practice to get there. Yaida, that was going to be by guessing and checking there. That's the method that I'm going to say forward facing to y'all. For those of you that I taught mental math with, you know there's other ways. But you know how sometimes you guess to divide, you'd be like, okay, 42 times 3, did that work? 42 times 4, that worked. 42 times 5. In this case, you got to do some guess and check, and you'll get 4. Yeah, definitely got to practice these. Definitely got to practice these. So with that, everybody, I'm actually going to go ahead and let you take a screenshot of the last question because I did go a little over explaining this one. So I'm going to go ahead and let you take a screenshot of this one because I do need to head out at 8, personal reasons. But I'm going to go ahead and let you take a screenshot of this right here. Let me get my face out of the way and let you take a screenshot of the next one. And if you'd like, I'll give you the answer. And your goal is going to be able to explain the problem, okay? That's the goal, to be able to explain the problem. And for those of you who are in the program already, tomorrow I got a treat for y'all. We got a class on solving quadratic equations. So if you've never learned how to solve quadratic equations, I'm going to show you tomorrow. It's going to be a good one. It's going to be a fun one because it's the first one I've done of this type in a while. So it's going to be a great one. And we also have quadratic equations coming out with guided practice videos and speed drills. It's coming out very soon. All right, so there it is. Okay, here's the next one on party people. And this one's pretty straightforward. So go ahead and take your picture, take your screenshot. If you look at the previous recording of this class, you will see me go through, I think, the next one as well. And a lot of these problems are already in the Math Bootcamp under Money Word Problems. So if you go to Money Word Problems, you will see these in there.
And before you go, if you like what you saw and you want to raise your score with thousands of practice problems just like that, so you can lower that test anxiety, raise that confidence, go to this link right here to check out the full program. There's a video that shows you exactly how it works, but you're going to get lessons, guided practice, worksheets, speed drills, and everything that you need to feel supported from day one all the way until you pass. Again, I'm Coach Anderson, and I'll see you soon.